Sure. Firstly, I'd say if you're struggling with the probability, you are not alone.
Yes.
Maybe as a way of feeling better.
Yeah.
You are not alone. There's a lot of us that may struggle with that section. However, there are a few fundamental basic things that we need to know.
What's your name?
Green! I got 100 on my dash, got 200 in my trunk. Name in the grab bags for my trunk. Like a rocker on the top of my vernacular.
Sure.
Let me start with the first one. The general rule of probability.
Yes.
Right? And I'm going to talk about just the terminologies thereof, and then you'll weigh in on some of the things. So the general rule of probability, what does it say? It says probability of A and B is equal to the probability of A plus the probability of B minus the probability of A or B. Now, where are you going to apply that? You're going to use that whenever they tell you that the probability of A is 0.3, the probability of A or B is 0.2, right? And they would say to you, calculate, let's say, the probability of B, and that's what you... Now, they would give you conditions. Firstly, they would talk about if A and B are mutually exclusive.
Sure.
Right?
Yes.
Let's talk about it.
Yes.
What does it mean when I've got two events that are mutually exclusive? It means these are events. So if you think about them as, in a Venn diagram, it means these are two events that would not meet, right? I always make an example with maths and maths lit,
Sure.
right? There's no student that does maths and mathematical literacy. Well, there are a few in IEB, you know those ones. Okay, but generally speaking,
yes.
you can't do maths and maths lit.
Yes.
Why? Because, think about it. On the same day that you're writing maths lit students are also writing maths literacy, right? So you won't be able to write both exams at the same time. So what are the chances of picking a random student in any school and find that they are doing maths and maths lit? Zero.
Sure.
There's no student like that. So what can I say? The events, maths and math lit, are mutually exclusive. They are not, they are disjointed events. That's the word that we use, right? So they will never find a point where they intersect together. So that's what mutual exclusivity is. Now, why does it matter? Because the moment they say to you an event is mutually exclusive, then you know the probability of A and B is 0. Important, nah?
Sure.
So if you go and plug it into that equation that we're talking about, the general equation, then you know where you've got probability of A and B, that's going to be 0. You're going to put a 0 there, right? Another condition that they put is if they say events are independent, right? So independent events. Now, if events are independent, what does it mean? Well, what it simply means is that the probability of A and B is equal to the probability of A multiplied by the probability of B.
Sure.
Right? Now, I was going to go through an entire thing where I show you what do we mean when we say that they are dependent events. Means the second outcome is dependent on the first outcome, right? But just remember this, that for independent events, the probability of A and B is equal to the probability of A multiplied by the probability of B. So that is what the general rule of probability is. Okay,
I would also like to start from the very, very, very beginning of probability, that each and every probability is greater or equals to 0, and less or equals to 1.
Yes.
So probability as a decimal will go from 0, including 0, and until 1, including 1. So if you calculating there, and you get your probability to be outside of that interval. It is something wrong that you did.
Definitely.
Go back to your work because
Definitely.
there is no such thing as 200% in reality.
In
There
mathematical
is no
terms,
such
yeah.
thing as
Yeah.
something that can happen over the definitive
Point,
ukuthi it will happen, yes or no. So there's nothing more than yes, there's nothing more than no. So no would be 0, yes would be 1. So, but we can have in between. With that, we are not sure,
Yeah.
and all of those things.
Sure.
And also remember that
Some of you are still unsubscribed. Shares has been telling me that over 55% of you have not yet subscribed but have been enjoying the content. Please, why don't you go ahead and do the right thing? Click on that subscribe button. Let's go back to the lesson.
the formula for probability is the event that we are interested in divided by the total
Outcomes.
outcomes of events, or maybe in our sample space, or so. For instance, let's take a roll of a die. So a roll of a die has six numbers, 1 up until 6. So what is the probability that when you roll a die, you will roll a 2? So you say, okay, in one die, how many 2s do I have? So that is the outcome that we want for the event. So we have 1, 2 in one die. So you will write 1 there, divided by what is the total number of outcomes. How many outcomes are in a die? So we said a die has 6 values. So that is 6 outcomes. So a probability of rolling a die and getting a 2 is 1 over 6.
Beautiful stuff.
Yes, that is that.
Beautiful. Beautiful.
So, and probability then does not end there.
Doesn't end there.
Then it goes there via
Yeah.
tree diagram.
Maybe let me just quickly talk about tree diagrams.
Yes.
So there are tree diagrams that are simplified, straight to the point, where you are looking at, let's say, picking a ball, right? Let's say I've got a number of 5 balls, 2 are red and 3 are blue, right? What are the possibilities of me picking a red, right? So in that case, remember, I've got 2 red balls, I've got 3 blue. So the chances of picking a red is 2 out of how many balls in total? That's 5.
Sure.
Right? But remember that the probability of picking a blue ball is a complement. That's what we call the complementary rule.
Yes.
Right? So the probability of picking a blue ball, right, would be 1 minus the probability of picking a red, right? So that would be 1 minus 2 over 3 in that case. 2 over 5, which would be 3 over 5. But in the same token, how many blue balls would I have? I would have 3 blue balls, right? Okay. So in that case, the possibility of picking a blue ball would be 3 out of the 5. Okay. Now, just remember, anytime you are looking at tree diagrams, they might not tell you, they might say to you, the chances of it raining today are 70%.
Sure.
They won't tell you about the chance of it not raining, right? So if the chance of raining is 70%, what would be the chance of not raining? That would be 30%, the complement of that. Okay? So you'll have the probability of rain, 70, and not rain, 30%, right? Now, if it rains, let's say Smakaleng decides to take transport, okay? So
Public
then
transport.
you're going to public transport, right? So you're going to say, right, when it rains, what are the chances of her taking a public transport?
Sure.
Then you're going to extend your probability that way,
Sure.
right? Your diagram. And then if it doesn't rain, what is the probability of her taking a transport? All of that will be provided to you. Those are conditional probabilities on tree diagrams. Okay, right. Now then they will say maybe what are the chances of Smakaleng taking transport on a
On
Tuesday.
the Tuesday.
So you're going to take the probability of it raining and her taking public transport, and plus,
Yes.
which means or the probability of it not raining and taking public transport.
Sure.
So those are what you would look at. And then the Venn diagrams. Hey, I could say a lot about Venn diagrams, but there's a lot to say. I don't know where to start. But it's always important for Venn diagrams to always start with information you are certain of.
Sure.
So for instance, let's say we've got a 3-set Venn diagram. The probability of doing math, science, and accounting.
Sure.
Right? If they say to me 5 students do math, science, and accounting, I am definitely sure of that.
Sure.
Okay? I'm going to put that right in the middle. Right?
Yes.
Where all of them intersect. But if they say to me 20 students do maths, right? Now that's not definitive, because they could do maths and something else.
Yes.
Right. So try to avoid populating that first, unless they say 20 students do maths only. Then you are definitely sure you're going to put that in that space where we only have maths and it doesn't intersect with anything else. As you know, on anything else, please go to my videos and watch.
Yes.
There's lots of them there. You'll see how we go about answering some of those questions. I think maybe to conclude, fundamental counting principles. What do you want to...
So first, not one of the questions that you need to not sleep. Because that's 5 marks, at most maybe 6, but you don't want you don't want not to sleep because of just a 6-mark question. But counting principles are important. So when you are considering things like with or without replacement, those things are important. And when we speaking of arrangements, so do we want to repeat the things that we are arranging? So we are actually facing books. So a way to arrange those books in order. How many ways can we arrange? So in a shelf, let's say there's a shelf I'm looking that there are probably 70 books. How many ways are there to arrange those books? So that would be so if I arrange the first one, so that would be I would have 70 books. But for the next position, I can only choose from 69 books. So that will be 69. Because I've placed the first one. And then I've placed 2 now. So the next position, 68, and so forth and so forth until the last one. Sure. And that would be 70.
I wonder why you went for 7. I think what I also want to just say in that regard, I prefer to use that positioning method, right? Rather to plot my positions and make my permutations based on positions, as opposed to the formulas. And I know, guys, that we've got formulas that we use, right? If this repeats, if that does not repeat, and all of that. You'll see, if you go and watch my videos, you'll see that, I try to use that block method, okay? I prefer it. It works much more efficiently. But of course, if you prefer formulas, Askis, I won't be able to advise you much on that one, because there's quite a number of formulae and there's a number of different ways in which that can happen. But you are quite right. I think in conclusion, they don't need to stress Kakulu on probability. It doesn't weigh a lot of marks. Okay, so it's a section that they can kind of make sure that if you understand it, you understand it. Yeah? But if you don't need to agonize too much about it. Maybe, let's take a question.
I wanted to ask, when you are given like a value and it has repeated digits, but the question does not mention that it's repeated or not repeated, do you still divide whatever you're given by the repeated values?
I think there's a question that you're doing
Yes,
today.
today. Yes.
Yeah.
So
Maybe because you are still warm from that question. Go for it.
So in that question, we were not explicitly told about such reputations, but in our calculations, we considered that because there is a chance when we do not consider the reputations, there is a chance that we would get exactly the same number. And if the question is asking us for unique arrangements, then definitely we need to take into consideration how many items repeat and so forth.
Sure.
So yes,
Sure.
I think in a nutshell that is
I think that's a very good one. It was a question that we did earlier on in class, and they didn't explicitly state that we need to consider repetition, right? But you sealed it quite well.
Yes.
You look for repetition, right? If it is that they said to us, we need to make unique numbers, right? Then we know, okay, in that case, using this number again would not give us a
Sure.
unique number. So in that case, we need to we need to consider repetition. Okay.
Yes.
Right, and so divide by it. Yeah,
Just a few things.
Okay.
So
Yeah.
the words at least or at most. At least or at most. So when we say at least, what is the probability that at least 5 students
Very important.
fail mathematics? So that would be at least 5 is 5 or greater, 5 or more. And then when we say at most 5, then that would be 5 or less. And also, at least 5 can also differ if 5 is not included in that x is greater than 5. That is also at least 5. But it starts at 6. So then we are counting, okay, so it means 6 going up. And usually, to calculate the probability of such problems, you will need to use the complement rule, because you can't calculate 6 to 1,000. If there are 1,000 events, you can't calculate 6 to 1,000.
Sure.
But at least you can calculate 0 to 5 and then subtract from 1, and
Yeah.
you shall get the rest.
Yeah, very good.
Yes.
Good.
Yeah.
All right. I think we want to wrap it up from
Yes.
here. I think it's been a very good, wholesome discussion. Please note, for those of you that are still struggling, please, I'd love to say to you, don't lose hope.
Sure.
Don't lose hope. NgesiZulu bathi akulahla sorry, akulahla umeleko ngafelwa.
Yo.
Apologize about that. I think because I've been talking a lot today, my voice is a bit froggy now. I'd love to say to you, just remember, sometimes we really think that maths is the problem, when sometimes it's just the way that it's been taught to us, the way that it's been presented to us. And maybe the lack of contact time with it, that is enough. And so for those of you that may be feeling discouraged, please, I want to say to you, don't lose hope, don't lose heart. Your future is still safe in the hands of God.
Sure.
Don't throw in the towel. For those of you who've had mental health issues during the course of this year, I also want you to remember that you are not the problem, okay? Unfortunately, we find ourselves in this system that requires us to perform all the time. You are assessed based on, how well you perform. You are either wrong or right, and that's sometimes isn't the way how the world works. So I want to say to you, if it is that you are not doing well in maths, give yourself, an opportunity. Perhaps for some of you, it might mean, you need to come back even in the next year, to rewrite. For me, there's no shame in that. Absolutely no shame. I went through that process myself, right? There are students at my center that are going through that process. There is absolutely no shame. Nothing wrong with that. Okay? So there is still hope for you. We will be hosting a number of workshops, right? Please look out for them. Pick a workshop that you would like.
Sure.
On the specific workshop, we are tackling specific sections, right? Please just look out. We will have more information on that. Probably Ushes will put it on the screens.
Yes, it's there.
Please look out. Just choose the workshop that you would like to attend on the specific topic that you want. We've really made it affordable, guys. We've really tried to meet you where you are so that it doesn't also break the bank. And for those of you that have been with us throughout the year, thank you so much. We really love you.
Sure.
Siyabonga kakhulu.
Sure.
Mr. Booty!
Yes.
Give it up for Mr. Booty!
Thank you.
Man, it sounds wrong, but his surname is Booty. Okay, that's right. Apologies for those of you who had something else. But yeah, from me, your favorite uncle, it's really been awesome being with you. I'll see you guys again next time. Whoa. For my crew at the back.
Choficho.
Yes.
Your final announcements.
Okay.
Yeah.
I see that you've addressed a number of groups. We forgot to address the group that are doing well and overconfident.
So yes. Yeah.
Be sure not to be complacent, because
Sure.
there's still time to be complacent. There's still time to drop the ball.
Yeah.
Don't drop the ball. And those will be my last words.
Sure.
Thank you.
I think that's a nice way of wrapping it up. It's really been a pleasure. I hope you guys will watch till the end. Subscribe, like, do all the nice things. We'll see you guys again on the next one for paper 2. Sharp.
Choficho.